11.6, arc length and sector area. Okay, this is pieces of circles. We're going to talk about measuring one thing in length and measuring another thing in area. You've already gotten good by now at circumference and area of a circle. This is a piece of circumference and this is a piece of area, which I go into explaining here. I give you these lovely formulas here. Arc length is x over 360 times 2 pi r, and sector area is also this mysterious fraction x over 360 times pi r squared. So what's with the x over 360 and what does that even mean? Well, if we're talking about, oh, you know what, I always forget to do this. Here's your questions on what you're going to be asked to think about at the beginning of the 11-6 part of next class. Anyway, these are the three sort of goals for this video. Have a look at that. Okay. If I have a circle and I tell you what the radius is, and I say, okay, we're going to talk about just a chunk of that circle, like maybe just this part right here, and you know, you've been used to finding the entire area, but what if I just give you this part? So we're going to find the area of this part. Or, I'll do one thing at a time. Okay, this is the area. Oh, it highlights more when I do it more than once. Does it get brighter and brighter and brighter? Oh, interesting. Okay, didn't mean to do all that. I guess I could have changed the color so it's not quite so similar. This would probably be really gross. Oh no, I guess the green's not too bad. Okay, so just the area. It's starting to look more like pizza now. Different kinds of toppings in it. Okay. Right, so I want to find the area of that thing. You would need to know a couple of things. You would need to know what's the radius of this circle. And I'll just give you one for now. We'll talk about it in general in a minute. And you would also need to know, like, how much circle are we talking about? You'd want to know that thing in degrees. You want to know this measure, this central angle, which, as you remember, is the same as the measure of this arc in degrees. This one looks like it's about, I don't know, 65 degrees. Let's say that. Okay, the area of the entire circle, think about this for a second, of the entire circle, that's a circle, that's not just a 0, the area of the entire circle is pi r squared. We learned last time. And here, that would be 64 pi. I like to think in exact answers. 64 pi is the area of the entire circle. How much circle are we talking about here? Well, we don't have the whole circle. We only have, drum roll please, here's where that whole thing comes from. We have this much circle that we're talking about. If the entire circle is 360 degrees, we only have 65 360th of a circle. Of means times, right? I want to know this fraction of this number, then all I have to do, all I have to do is multiply those together. Why am I making a fraction? Yeah, it's this fraction of that area. Get out the calculator. All right, 65 360ths times 64 pi. I like to do this because I like exact answers better. This is actually 104/9 pi. Let's say it that way. And I started to tell you last time about the big deal they make about exact versus approximate. This would be the exact answer because it has a pi symbol in it, and that's the only way I can really call it exact. As soon as I go to the calculator and I hit the pi symbol, I go times pi. Remember, I left this as a fraction before I needed pi for it because I just multiplied by 64. There's really a 64 pi there in the final answer, so I just found the part that's not pi and I put a pi there. So to find the pi now, I do that, and with pi it's 36.302, and as many decimals is as good as I want to be, but it's never going to be exact. Oh, how about 303? Which is also useful for other reasons. And sometimes in math we like one or the other better, and both are available to us. Okay. Believe it or not, further in high school you're rather going to see this one than this one, but they're both equivalent at some level. Okay, so that's the thing about sector area. I guess I should tell you what this is when it's all over. This was finding the area of the sector, and that sector was the green thing there. Alright, so let's do a piece of a circumference, which would be arc length, which is the other part of this title, of this section. Arc length would be, okay, what if I want to know the length of part of this thing? Like, I don't want the whole circumference, I just want a little piece of it. Well, I would need to know a couple of things. Let's make a more interesting angle. Oh yeah, it's darkening again when I re-highlight. That's freaking me out. make it look the same. Okay, I still really can't do it. Now it just looks like an orange with blue mold on it. Okay. Right, so I would need to know, again, I would need to know how long this radius is. I would need to know the angle in between those. Let's say the radius this time is something more interesting like 12, and this angle looks pretty big. It looks bigger than 120, but I used 65 last time, so I don't want to just end with a 5. I'll make it a little more cool. Okay, say it's 128, and I want to know the length of this arc. Well, I know the measure. This is one of the first things to talk about in the notes. The measure of arc AB is what we did last chapter. The measure of arc AB is 128 degrees, but we're not talking about measure of arc here. We're talking about the length. The length of AB is not something that I would measure in degrees. The length is like a length. I would measure it in whatever length units I'm using. I'd measure it in centimeters or inches or whatever that is. So, again, this would be an exact and approximate here too. I'll change to red here this time. The circumference of the whole circle, which is what this blue thing is part of. It's part of the circumference. It's not the entire circumference. It's a portion of the circumference. But I'm going to find it by knowing what the circumference is first and then chopping it up correctly. The circumference is 2 pi r in general, which here is 2 pi times the radius, which is just 24 pi. But remember, I am not talking about the entire circumference. I'm only talking about this much. How much of the circle is this much? Well, it's the same magic fraction as last time. By the last time, I mean last fraction. Last problem. It's 128 3/60ths of the thing. I don't need to simplify that. I can just say, I know I want 128 3/60ths. I want that fraction. I want that much of 24 pi, and that's my final answer. Calculator time. 128 3/60ths. I can move this over so you can kind of see it. 128 360ths of 24. It's kind of a yucky fraction, but I can figure out what that is. That's 128 15ths of pi. 128 15ths of pi. I can say it that way. And that also equals approximate answer like 26.808, I'll say. Did I get that right? Second thoughts about that. 26.808, yeah, sure. Okay, so about that many whatever units. This is in centimeters, whatever. Okay, so again, this is exact. This is 15 down here. This is exact because it's got the pi in it, or it might have a square root in it, and this is approximate. All right. Okay, now, armed with just those couple of things, you could answer some pretty sophisticated questions. Like, we could even find the area of, okay, I'm going to go straight for something crazy here. We could find this area here. This, I think if I don't lift the pen, it's not going to double highlight anything. All right, I'm trying to find this area here, and I might give you some crazy angle outside the circle. And remember all that stuff you learned last chapter about, it's kind of fun, all that stuff you learned last chapter about arcs and angles and intercepted chords and the angle inside the circle and the arc and the side the angle and the half and the double and the subtract and divide by 2. All that stuff is going to be sort of back on the table again for finding areas such as this. Now this is kind of crazy. I am looking at a circle here, and let's think about what I might give you for this. I'm making this problem up as I go. I might give you the radius of that circle. Of course, I'd probably have to give you the area of, oh, sorry, not the area. I'd have to give you this angle here. Well, you know what? Maybe I'll just give you this arc and this arc. Or maybe I'll just give you, oh, okay, let's not make it too hard right away. Let me give you this arc. Say, oh, that looks like it's close to 90. Let's say it's an 80-degree arc. Oh, I want to give the given stuff in black. Just a second. Okay, so I thought about this a little more, so you wouldn't have to listen to me think about it. And I made up some measurements for things we might be given here. And I might be able to ask, okay, what's the area of the purple? Radius of the circle is 20. This arc, and I just mean the arc that it sort of looks like it is here. This is 110. This is 80. And this angle out here is 50. So what's the area that's of the circle that's inside that angle, basically? Well, I know that this 50 has to be the same as this arc minus this arc. Because I think I'm going to want to know that. I don't know, maybe I'm not going to want to know that. But think about how I'm going to divide this up and do this problem. one way to do this is think about, okay, I can take the whole area of the circle and try to chop off these orange parts that I don't care about. Actually, right now it looks kind of nice to try to do that. Those little orange parts, though, think about it, are not sectors of a circle. You got to be a little careful. They're not the same shape as this pizza thing. It's not just simply that. To get the area of what's called a segment of a circle, I don't know if our book calls it a segment or not, but that's what you can call that thing. If I want to try to find the area of something like this shape, if I have a circle and I want to basically just chop off a little section like that, the part that's outside the chord, and try to find the area of that stuff. This thing out here, this is called a segment. That's not really a sector of the circle. The sector of the circle will be all of this, including the radius and everything, or all the stuff inside here too. So but look what I've drawn here. I've drawn a triangle. So I could take the sector minus the triangle, and I'll get the little fingernail kind of shape out there. Okay, so let's go back to what we're doing. Let's just try that. Let's call this extraneous information, and let's say we're going to find that sector here, and I give you the radius of 20, and we'll try to find this sector and subtract this triangle. And we'll do the same thing up here. We'll find the sector to 80, and we'll subtract the triangle. And then when I know that piece and that piece, I'll subtract those from the entire area of the circle, and I'll have the whole thing. So if that makes any sense, let me write out the plan here. The plan for area of, and I'll make a little subscript thing that looks like what we're trying to find the area of that shape, is going to equal area of circle minus, okay, now what we're going to try to do then is we're going to do area of segment 1 and the area of sort of the lower one that looks like that. I'm taking the area of the full circle and I'm subtracting out the orange things. Well, what are the orange things? I'm going to find the orange things by doing area of sort of this sector here. Whoops, not plus. That even by itself is going to be minus the area of the triangle. Now you know which triangle I mean when I just do that triangle. And this other sector is going to be area of the segment is going to be the area of the sector minus the area of the triangle. Okay, so I need to find all these parts. I need to find this triangle, I need to find this whole sector, this triangle, this sector, so I can subtract off the orange stuff. Okay, let's do this triangle right here first. I know this is 20. I know this angle has to be 55. This is starting to look familiar. We do this all the time now. I'm going to have to use trig to figure out the area of this circle. Sorry, triangle. The area of this triangle right here. The area of the circle is easy. It's 20 squared times pi. For this triangle, I'm going to want to know this length here, which is, if you remember, up to this point. 20 times the sine of 55. And this one in here is 20 times the cosine of 55. So the area of that triangle is going to be, which is this one here, is going to be half times, now the whole base down here is going to be 40 sine 55 times the height, which is 20 cosine 55. I could do that in decimals. I'll do that in a minute. I'll pause because I'm going to have about a minute and a half on this video. I'll pause and do it on calculator and I'll come back to you. Same sort of deal here. This thing is going to be 40 degrees. These are still 20. So this part here is 20, what is it, 20 times the sine of 40. And this one is 20 cosine of 40. Alright, so I did those two triangle areas on the calculator. To save some time, I'm down about 45 seconds here. Now I need to find the area of the entire sector, so I can subtract and get that thing. The area of this sector is the thing we just learned. It's going to be, let's do it up this way. It's 80/360ths of pi r squared. Now that was the easy part, right? Okay, so I went ahead and did that. This is the area of this whole big sector up here. Here's the area of this entire big sector down here. Now I need to subtract to find the purple part, or sorry, the orange parts. Okay, and I've done that. Here's the area of this little orange part. Here's the area of this little orange part. Now I need to subtract those from the circle. Okay, so here's area circle minus those two orange parts, and that's my final answer. Phew, barely made it under the gun. I will see you in class.